Today, students, we're going to talk about the correlation coefficient, which is R, and understanding what that value means. Before we begin our discussion on R, let's first kind of remind ourselves what a scatter plot is and what a line of best fit is. So here we have three of the same graphs or scatter plots. The only difference is they each have a line that's passing through them in a different place. So first, a line of best fit or a trend line is simply a line that best models the data of a scatter plot. And this trend line should always pass through the middle of the data while also following the trend. So when we observe the three scatter plots, we can see that the orange line is passing through the center or the middle of the data, and it's also increasing just like those points. The blue line is still increasing, but it's passing beneath all of the points. And then the green line is increasing, but it's increasing far faster than these points are. So the best line of best fit would have to be the orange line because it's the only line that meets the description down here, which that it should pass through the middle or the center of the data, and it follows the trend. Another observation for the trend line is there should be points, an equal number of points above and below the line, which the option A or answer A is the only one that shows that, whereas the other one, this has every point above the line. And for the green line, there are more points above the line here than there is below the line here. So now that we've kind of reviewed what a scatter plot is, what a line of best fit is, then we talk about the correlation coefficient, which is the variable R. So this tells us, or this is a numerical value that measures the strength of how well the line fits the points. It also determines how closely the equation of that trend line models the data. And so we're going to look at the correlation coefficient R is going to be a value between -1 and +1. Our correlation coefficient, again, can be any number between -1 and +1. The closer that the value of R is to +1, that just indicates that the points are a strong positive correlation or a strong positive relationship, meaning they lie on a perfectly linear straight line. As the numbers get smaller than 1 but closer to 0, they become less and less related. And if R is ever 0, then there's no correlation. Or if R is close to 0. Then when R becomes less than 0 and closer to -1, that just means the relationship is now a negative relationship. And just like +1, if the value of R is ever -1, that means there's a very strong negative relationship. So again, the points will lie on a straight line, but now they just go in the negative direction. And so that's what we want to be able to discuss today as we look at graphs or scatter plots. Can we estimate the value of R based on how the graph looks? So here we have some scatter plots. And first, I want to talk about what do you expect, or which one of these do you expect to have a stronger correlation? So in other words, we're looking at stronger correlation is simply telling us which scatter plot has data that is closest to being on a line. So when we think about that, we have 6 different scatter plots. Each of them are different, but the one with the strongest correlation or the strongest relationship is going to be the graph of number 6 here, because these points are more clustered together. They're all decreasing overall, and they would be the closest to lying on a, if we were to draw a line here, so I'll actually draw the line, I can get more of these points to pass through this line than any other graph on this on this grid. If I were to draw lines on the other ones, then I won't have as many of the points passing through this line than like number 6. So we can expect that the scatter plot for number 6 actually has the strongest correlation because of that fact. So the value of R will aid us in making predictions. It can tell us how accurate our predictions are going to be. And so this is mainly why we care about the value of R. A stronger R means that the data can help me guess what will happen if the pattern continues. Since R basically tells us how strong the relationship is between the X value and the Y value. And so now it's time for us to try and use our estimation skills to see, hey, can we generalize or can we determine what the value of R is for these particular graphs based on how the scatter plot looks? There is a way for us to find R mathematically in the calculator, but first we just want to estimate. So earlier we said that if the graph was perfectly linear, meaning the points fell on a straight line, that means the R is either going to be +1 or the R is going to be -1, depending if the points are increasing or decreasing. So as we look down here, if we observe any scatter plot or any graph where the points lie on the line perfectly, then that would indicate a strong positive or a strong negative relationship. And so I see 2 of those ones. I see the first one here. These 3 points all lie on the green line perfectly. And since they're decreasing, I can say that the relationship is -1. Because that's a very strong negative relationship. They're all on the same path. They all have the same trend. The other one would be the very last one. These 5 points all lie on the green line. And so they are increasing, which indicates a very, very strong positive relationship. So I can say that that's 1. Now, those are the only 2 that have the strongest positive or the strongest negative relationship. Now, if I look at the graphs that remain, these points overall, they're decreasing. And these points overall, they're increasing. But we want to try and estimate what the value of R is, which tells us how strong the relationship is. So this green line passes through the middle of those points, which is good. So it's a good estimation of those values, but they're not very close to the green line. So with this particular one, we could say that since they're decreasing, the value of R is going to be negative. And so I could say that the correlation coefficient is -0.75. Now, for right now, that's a value that we're just estimating. It could be a little higher, it could be a little lower, but that's the amount that I'm estimating because -1 indicates that it's a perfect negative relationship. And this is far from perfect because there's no points on the line. Similarly, this is going to be the same case. This is increasing, so it's positive. There are no points on the line. So since it's positive, I can say that I'm estimating the value of R to be, let's say, +0.75. And again, we could say that could be a little higher, it could be 0.8, or it could be a little lower, it could be 0.65. We're just estimating right now. And then lastly, we have this graph with no line at all. No line means that it's impossible for us to determine what the relationship is. We don't know if it's overall increasing or if it's overall decreasing. So because there is no correlation or there is no relationship, then the value of R that is best suited for this information would be the value 0 because there's no correlation at all. All right, based on what we've talked about, I want to see if you can determine what value of R best represents each scatter plot below. So for these A through D, I want you to determine which one of these correlation coefficients would actually describe the relationship of the data in the graph. All right, let's see how you did. Remember that the closer the points are clustered together, then we can expect a higher correlation coefficient. And since these are Since this correlation coefficient is 0.96, it's almost perfectly linear. It's almost perfectly strong positive. Since they don't all fall on this orange line, which is why it's a little less than 1, but they're all closer together and they're all increasing. So that's why this is so high. And as we move down, we can see that the correlation is getting less and less and less. And here at the very beginning, we have a very small r, very close to 0, which would indicate no correlation. Since these points are all spread out, we can't really tell what's happening. Even though there is a line drawn here, we really can't tell if the points are overall increasing or what they're doing. So if you were able to match those, good job. If not, don't worry about it, because we're going to do more talking about the correlation coefficient. And then up next, we are going to actually find the correlation coefficient in the calculator to describe a set of data. And so let's go ahead and do that. Here we have a table of values that we want to be able to find R for to describe the relationship between the X values, which represents a child's age, and the annual cost, which is the Y value. And so this table just shows some predicted cost to raise a child back in 2003. And so we're almost sure that that cost is increased. But still, we can utilize this as in our example to find the value of R to check the relationship between these X values and these Y values. So go ahead and get your calculator so we can do this part together. And this part should be fairly quick because a calculator is going to find the value of R for us. So first thing we want to do is go home and we want to add a new document. And if you're asked to save, select no, never save that information. And we want to add a list in a spreadsheet. So that is number 4. So pick number 4. And then in here is where we're going to input or type in our data. To do so, we're going to go up to the very top where it says A, and we can either type in X or we can type in what X represents. In this case, I'm just going to put X for now. And then we need to arrow down until we get to the first cell, and then we can type in the child's age. So 3 all the way up to 15, 3, 6, 9, 12, and 15. And then to enter in the Y values, just arrow over, go back up to the very top of the table, put Y, and then arrow down, and then let's type in the numbers. So 10,700, 11,700, 12,600, 15,000, and 16,700. So those are my X and my Y values, and they have to be entered into the table for us to be able to find R. So the next step for us to get R, we're going to have to add a calculator page. And to do that, we need to hit Control and Document, because that will allow us to add a page. And we want to do number 1, add a calculator. So notice we should have 2 tabs up here. 1.1 was the information we typed in. 1.2 is where we're going to now find the correlation coefficient. And so to do that, we need to hit Menu. And this is actually a statistics feature that we're talking about. And we're going to do some statistic calculations, so number 1. And then we want linear regression, number 3. If you notice, it says mx plus b, which is the linear function that we've talked about most of the first semester. So we click that, and our X list was simply just X, and then hit Tab. Our Y list, we typed in Y, and so then we want to hit Tab all the way down till we get to OK, and click OK. And so here we have a lot of information. We have our slope, which is 510. We have our y-intercept, which is 875, and we also have the R value, which is 0.98. That R value, it just tells me that, hey, that information between the age and the cost is nearly perfectly linear.